call is now being recorded.
Good morning to all of you. Let us start the session. In previous session, we already completed the laws of set theory. Let us quickly recap. What are those laws? Yeah. So we already seen what is identity law. Any set union with it is not exactly with respect to any other set. We want to know what operation that we can perform with null set or union set so that we can get the same set itself. So with null set, we can perform union operation to get the same set. Identity means whatever set A is there, you will get the resultant set A itself. Similarly, domination law is nothing but what is that operation with universal set and null set so that we will get universal set and null set, that is domination law. Idempotent law, if we perform the operation with set itself, what exactly we get? Double complementation law. Then we saw that union and intersection obeys commutative property, that is whether you perform A union B or B union A, both are same. But this cannot be true for any other operator, like set difference A minus B do not hold equal to B minus A, may not be always. So therefore set difference is not commutative law. Okay, it is not satisfying commutative law property. So basically whatever laws we are discussing, it is with respect to the union operator and intersection operator, except this double complementation law. Now, what exactly we are doing in associativity law, that if we perform either union or intersection with respect to more than two sets, that is 3 or more than that, then whether we perform operation on B union C and then A union with that, or whether we perform A union B and then union C, associativity property is holding. Distributive law, outer become inner, inner become outer. De Morgan's law, A union B bar equal to A bar intersection B bar, and blah blah blah. So we already seen these two laws now. A union A intersection B. See, here we are having two sets, but 3 times the operation means there are 2 operations that we are performing. That first we are identifying A intersection B, and then we are combining with set A. So you are aware about that. A intersection B is nothing but whatever the common elements of 2 sets are there. So it is also belonging to A as well as belonging to B. So whatever elements that are belonging to A, and you are doing union with that same set itself, you will get definitely A. Or if you are doing A union B, and then you are taking intersection of that with A, definitely you will get A. So this is absorption law. Complement laws, A union A bar, you will always get universal set, and A intersection A bar, you will always get null set. So this is what we already seen in the previous class. With respect to this, we will continue our session now in a quick manner. I'm leaving this as a exercise. Proves that A minus B union B minus A, that is equal to A union B. So basically what exactly you need to prove here, LHS is subset of RHS as well as RHS is subset of LHS, and then with respect to 1 and 2 you say both are equal sets. I'm just leaving this and just going ahead, so that definitely we will test this, may not be today but later on, because I need to cover today some more universal properties as well as we need to start today relation. So let us try to understand. Yeah, in general, if you do have some sets like A1, A2, A3, A4, this is just a union. Just like in your mathematics, you are having summation series, summation formula, summation I equal to 1 to n. maybe you are having some terminology having subscript I. Okay. In the similar way, you are having some sets like A1, A2, A3, and you want to perform union operation. So in generalized way, you have written I equal to 1 to n. There are n sets, and A is just a terminology like A1, A2, A3, and An. And what exactly you are doing? A1 union A2 union dot 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 An. That's it. Nothing new. So we don't want to go in this. Let's go ahead. Yeah. This is what we need to understand today. What is the principle of inclusion and exclusion? Okay. So this is one of the application of set theory wherein we want to play with the cardinality of a particular entire set or partition of a set. Okay. So let us take one example and then we will try to understand what is principle of inclusion and exclusion. So there are 217 CS measures. It is just like you can say it is one of the set having these many elements. That's it. 157 are taking, see, 217 CS measures. 150 CS measures means what? There are certain students. Okay. Out of that, 157 students takes this course, 145 students takes this course, 98 students takes this course, and we want to find out how many are taking neither of this. So there are total 217. That universal set is given to you. The cardinality of universal set is 217. This is set A, this is set B. So you have been given cardinality of set A, you have been given cardinality of set B, and you have been given cardinality of set A intersection B. And what is asked exactly, you want to know how many of them taking neither this nor this. That means what? A union B and complement of that. That is what exactly you want to find out. Cardinality of that. That is what exactly you need to find out. So what is principle of inclusion and exclusion? Let me just check whether it is covered here. No, let's go ahead. Okay. So the scenario is something like this. You are having 157 students who are taking set, you are belonging to set A, 145 students who are belonging to this, and 98 are taking both. So this is very easy that you can able to identify that you want to find out this shaded portion. Means neither of these two courses they are taking. So you are aware about that there are total 217. Out of that, this is set A and this is set B. So if you add these two together, 157 plus 145, you will get students who are taking courses in this and courses in this. But this portion is counted here in this set A as well as in set B. So we need to eliminate once. So therefore, we are eliminating that intersection part, that is minus 98. So if you do this, you get 13 students which are not participating either in set A nor in set B. Any questions in this up till now? Is it clear or not? Please let me know. I'm waiting to hear. Is it clear or not?
Yes, sir, it's clear.
Yeah, yeah. Okay. So this is in general, very simple example we understood. What is principle of inclusion and exclusion? So we need to understand in a generalized way. Means if we are having more than two sets, this is one of the example like we are having set A, set B, set C. Okay, and I want to know means how many elements are belonging to all these three sets. That is A union, B union, C, and cardinality of that. So this is exactly the general principle of inclusion and exclusion, how we can apply. It is something like this. To answer this, if you want to identify A union, B union, C, definitely what exactly we are doing, we are adding cardinality of A, we are adding cardinality of B, we are adding cardinality of C. Okay. But you can understand in this, whenever you are taking this cardinality of A, there are certain few segments which are also which may belongs to set B, set C, or which may belongs to all three sets also. So therefore, what exactly we are doing now? We are eliminating the common element. So what exactly we are doing now? We are since we have added cardinality of A and cardinality of B. Let us take these two into consideration, A and B. Since we have added this, we want to eliminate this common portion. So therefore, minus cardinality of A intersection B. Similarly, we have taken set A cardinality of A plus cardinality of C into together, and this is either it is included here or but both place it is included. So we need to eliminate one cardinality of minus, that is I will just have here on slide, minus cardinality of A intersection C, because it is already counted twice. Okay. Similarly, we are eliminating B intersection C because it is already counted. So by doing this, what happens? We have eliminated this portion two times. One in between A and B, and another is between three times basically. One is in between A and B, another is in between B and C, and another is between A and C. I am talking about this portion I am highlighting right now. Okay, here. So already this is included in one of the cardinality of either A or B or C, and then again we have deducted twice. It is something like that. So therefore, we are again including that portion. What is that portion? We are adding that cardinality of A intersection B intersection C. So this is exact answer. What is the cardinality of A union B union C? It is basically, in general now I am talking, whatever sets you may have, A1 union B, A1 union, A2 union, A3 union, dot 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 AN. What exactly you are doing? You are starting with individual cardinality. You are taking that into consideration and you are just summing up. That's it. See, alternate plus minus. So everything is plus now. And then what you are doing, alternate, see, it is plus now. Then now you are just increasing dimension. That up till now you have just considered only one set. So now we are starting with minus, and now we are having order 2. That means you are taking two sets into consideration, and you are doing now intersection operation. Basically, you are doing union here, so you are doing here intersection. So all possible intersections, you are just having a minus, having degree 2. And then again alternate, see, plus minus plus, then you are just increasing the order. Instead of 2, now you are having 3 sets, and you are just performing intersection and you are just adding. So likewise, if you do have here union D, what will happen? It will be cardinality of A plus cardinality of B plus cardinality of C plus cardinality of D minus all possible combinations of two sets intersection plus A intersection B intersection, all possible combination of 3 sets like A intersection B intersection C, A intersection B intersection D, B intersection C intersection D, and likewise. Okay. And then again minus A intersection B intersection C intersection D. This is in general. So this is exactly the principle of inclusion and exclusion. If you are having two sets, pretty simple. If you are having two sets, what is exactly happening in two sets? If you do have two sets cardinality of A union B, so applying the principle of inclusion and exclusion, it is cardinality of A plus cardinality of B, and then alternate plus minus. So here which is minus cardinality of A intersection B. So this is what principle of inclusion and exclusion for this two sets. So for 3 sets, it is something like this, and for 4 sets also you are able to do it. So I'm sure now this is clear. Please let me know very quickly whether this is clear or not. In chat box, quickly respond yes or no. If any questions, I will immediately solve your question. Don't hesitate to ask question. All right. If there are no questions, let me proceed ahead. So this we already discussed. What about 4 sets? So this is in general. You do have n sets. Then you do summation of cardinalities of individual sets. Then minus 2 sets, and so on. You are just going in nth order. Proceeding ahead. mm, okay. Let's add this string. Yeah. So it is not different. It is something like that. What exactly we are talking right now. So let us say you are having some universal set containing some n elements, and you are having one set which is subset of universal set, and then the characteristics vector of A is the n vector. Basically, you do it is nothing new. Basically, what is this? Whatever the set that you are having, whatever the set that you are having, you are just talking with respect to the membership value of what is the membership value of all these elements in this set. This is what exactly we are talking. So x1 belongs to set A. So membership value x1 belonging to A is 1. X2 belonging, what is the membership of x2 belonging to A? It is 0. It is not belonging. X3 it is belonging. X4 it is not belonging. X5 it is belonging. X6 it is belonging. That's it. This is just a membership value of all the elements belonging to universal set, whether they what is their membership value in set A. So this is the membership value. That's it. Similarly, if you talk about this, x1 belongs to b2 0, it is not belonging. X2 belonging, x3 belonging, x4 not belonging, x5 not belonging, x6 belonging. That's it. And now you just want to identify. It is just a visual representation, nothing else. You want to perform A union B. It is simply the elements. See, we are talking about all the universal sets. So here all the elements belonging to universal sets are there. So when we talk about A union B, it should be either A in A or B, somewhere it is belonging. So it is also belonging to A union B. We don't have to discuss as much. This is pretty clear. Let's go ahead. That's it. So what exactly we will do now in today's session, uh, we'll quickly start with another topic, that is relation. These are all book chapters, not my slides. Let me just quickly check. Yeah. So I think 1 minute. Yeah, we can start with this. I'll start. So relation is what is relation is basically relation is operation on sets, two sets, at least two sets. Basically, relation is a binary operator. R is a binary operator. For example, when you talk about let us say what is the relationship between me and you. So let us say there are two sets. I'm talking right now element. Let us say Satish Salunke is one element, and maybe another element is like your name. Okay. So if I talk, what is the relationship from X to Y? That is Satish Salunke to you. So Satish Salunke is a teacher of Y. So is a teacher, is a relation. So R connects one entity from another set to another entity to another. Means basically a binary relation. Let me just use the laser. Okay. So a binary relation from set A to set B is a subset. Means what? Relation R is basically subset of A cross B. You already seen what is A cross B. It is ordered pair. A cross B is what? It is ordered pair A comma B, such that A belongs to capital A, set A, B belongs to capital B. So you are having all possible ordered pairs A comma B. And now if I say a particular relation, if I mention a particular relation R that is from set A to set B, then definitely whatever that relation R is itself also a set containing ordered pairs A comma B such that it satisfies that relationship R. And this relation R is always subset of A cross B. Let me just check whether any example. Yeah, if you can take this example, you can see here, if you take A cross B, there, can you tell me what is the cardinality of A cross B? If you perform the Cartesian product A cross B, what is the cardinality of A cross B?
15.
How?
3 into 5 cardinality of A into cardinality of
Yeah.
B.
So you are having all possible combinations like A1, B1. This is one element belonging to A cross B. A1, B2, A1, B3, A2, B1, A2, B2, A2, B3, A3, B1, A3, B2, A3, B3, A4, B1, A4, B2, A4, B3, A5, B1, A5, B2, A5, B3, likewise. Okay. And you have been given relation R. It is also from set A to set B and having all these elements like A1, B1, A1, B2, whatever. So you can identify this relation R is subset of A cross B. Okay. So you can see visually like this. This is set A. This is set B. These are all the elements A1, A2, A3, A4, A5 belonging to set A. B1, B2, B3 belonging to set B. And you can see there are certain elements which are having relationship with some elements in this set B. So when we say there is a relationship, just check the pen. Wait. Yeah. So when we say there is a how to show the relationship, it is represented like this. There is a relationship from A to B. This is the way you are writing the relation symbolically, and you are just mentioning. Oh, just a minute. When you say there is a relationship between A to B, you are just mentioning A to B. There is a relation R. Okay. R is the name of the relation. It may be R1, R2, R3 as per your convenience. You are just giving the label. So in this case, this is called as domain of relation R. And this is called as codomain of relation R. Please excuse my handwriting. I'm not able to write properly. So try to understand now what is domain of R. Domain of R is set A. What is domain of R? Sorry, codomain of R is set B. What is the relationship between A to B? This is R. So it is not always like that. There is only always one relationship exists between A to B. You can have n number of relationships between set A to set B. Okay. Whatever relationships are there between set A to set B, it is nothing but it is a set having collection of ordered pair A comma B such that it satisfies the given relationship R. And all such relationship between A to B are always subset of A cross B. That is A Cartesian product B. That's it. Yeah. So what is this? A relationship between element of two sets is the subset. This is just the summary that we are talking right now. Yeah. A relationship between elements of two sets is a subset of Cartesian product. Note the difference between a relation and a function. This we will discuss later on. This function you cannot understand right now. If an ordered pair A comma B belongs to R, we say that A is related to B. If A comma B, whatever that element is, belongs to set R, that indicates element A is related to element B. In notations, we denote like this. A is related to B. A is related to B by relationship R. That's it. So for example, here A1 R B1. That's it. Okay, going ahead. A relation on set A is a relation from A to A, that is subset of A cross A. There can be many relations. For example, if I take two sets, this is okay. Uh, what is this meaning exactly? I'm just giving to you. For example, you are performing operation, means you are just relating set n to set n itself. What is, there can be many relationships. So one of the relationship is given to you R1, that is it is collection of all A comma B such that A is less than or equal to B. Okay, this is one of the relation. On set n to n, there can be another relationship R2 such that A and B both belongs to n and A by B belongs to set Z. There can be another relationship R3 such that A and B both belongs to n and A minus B is always equal to 2. And likewise, there can be many possible relations. Uh, okay, before continuing this, let me check whether I do have an example. Yeah, so let us take some example to understand. We'll see this example by learning some property. So still, what I will do, I will post some exercise with you to answer. Will be better. Okay. Let me take a relation B is related to, there is suppose R1 relation from B1 to B to C, and R1 is a relation such that, what is this relation R1 is that mm, let us say A is less than B. Let us say this is the relation. R2 is another relation from B to C such that, let us say uh, where A is equal to B. Okay. I may take another example R3 such that A is multiple of B. I may take another example R4 is, let us say B is divisible by A. So now I want to know what is R1. Yeah, come on, everyone, tell me now. You can work out now in your notebook. You can note down. There is a relationship. This is in general I have written. I will write now B is related to C. There are all these possible relationships like R1, R2, R3, R4 from B to C. One of the relationship R1 says that see A is belonging to B and B is belonging to C, and When you, this R1 is having all the elements of A comma B such that A belongs to B, B belongs to C, and this is holding this property, that is A is less than B. So come on, identify what is R1. What is the cardinality of R1? What is R1? And okay, let me know the elements of R1 quickly. If anybody wants to unmute, you can unmute and tell me quickly what will be the
Sir,
element.
we have
Yeah,
to write from these sets which are given, this ABC.
these two sets are here. Set B and set C is here. There is a
Yes.
relationship between B to C. What is that relationship? R1 is the relationship. Yeah, tell me now.
So it cardinality will be 9.
No, let me know the elements first of all.
So 1 comma 3.
Just a minute, just a minute. Let's see, let me just. Yeah. Now tell me what are those elements of R1?
So 1 comma 3.
1 comma 3. Okay.
1 comma 4.
1 comma 4. Correct.
1 comma 5.
1 comma 5. Correct.
1 comma 2.
1 comma 2. 1 comma 5. 1 comma 2. Correct.
1 comma 9.
1 comma 9.
2 comma 3.
2 comma 3.
2 comma 4.
2 comma 4.
2 comma 5.
2 comma 5.
2 comma 9.
2 comma 9.
So that's it.
Okay. So this is your set R1. R1. Wait a minute. This is your set R1, which is a relationship from B to C. So you can identify if you take the Cartesian product of B to C, the V cross C, definitely R1 is subset of B cross C. So cardinality of R1 is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now let us go ahead with R2. Yeah. Anybody wants to continue?
So R2 will be 1 comma 1.
1 comma 1.
2 comma 2. And
2
9
comma
comma
2.
9.
9 comma 9. Perfect. Very good. Appreciate. Well done. Next, R3. A is multiple of B.
Sir, 1 comma 1,
1 comma 1. Yes.
2 comma 2,
2 comma 2.
2 comma 10.
A is multiple of B.
Okay,
I
sorry,
am not
5
talking
comma
about
10.
B. Hmm?
Acha, no, then only this much.
A is multiple of
2
B.
comma 4 also. 2
What is
comma
meaning
4.
of this? When you say A is multiple of B, give me example. Irrespective of the set B and C. When you say A is multiple of B, what is example of this statement? Is 5 is multiple of 10? Yes or no?
Yes.
Yeah, come on. 5 is multiple
So
of 10.
10 is multiple of.
My question is precise. Is 5 is multiple of 10? Yes or no?
No.
No. Is 10 is multiple of 5? Yes or no?
Yes.
Yes.
Now answer the R3.
Sir,
So
6
2 comma
comma
4.
1 comma 1 again beginning.
2 comma 2.
2 comma
2
hmm.
and 6 comma 2.
Completed, is it?
Sir, I have a
No,
doubt.
sir, sorry,
Yes.
sorry, 4 comma
How
2.
6 comma 2?
Sir,
Let me
sorry,
know.
4
Wait, wait,
comma
wait, wait,
2.
wait, wait. Let me know the doubt first of all. What is the doubt? Yes,
Sir, in R2 it is A is equal to B, right? So,
So
yes.
it will be 4 comma 2.
Wait. Let me understand the doubt of Viraj. Yes, Viraj.
sir,
Yes,
in R2 it is given A is equal to B. So
yes.
we have to find what.
Find what means what? A is belonging to set B. B is
But
belonging to set
relation is
C.
B, relation C.
Pardon?
Relation is B,
This
B
is the
belongs
name of
C,
the
right?
set. This is the name of the set. Set B. Don't
Oh,
get
okay,
confused.
okay.
This is the name of the set C. This is in general. Element A belonging to set B. Element B belonging to set C. In general. Are you clear or not, Viraj?
Yes, sir. Samjha.
Okay. Your doubt is clear?
Yes, sir.
Yeah. So proceeding ahead, R3. Come on, tell me quickly.
Sir,
Any
that is not
elements are
6.
there?
I made a mistake. It
Pardon?
is 4 comma 2. Sir, that is 4 comma 2. I
4
told
comma
wrong.
2. Set B is containing 1, 2, 9, 10. Set C containing 3, 4, 5, 1, 2, 9. Okay. So what should I write here? 4 comma 2. Okay. Any other element? Am I writing correct or wrong? Every student, don't take it blindly.
3,9, 3,9.
Sir,
No,
I
no,
have
4
a
Sir,
comma.
doubt.
9.
Yes,
Sir,
9
I
doubt.
have
comma
a
9.
doubt. No,
Let us
doubt
try to
regarding
understand
10,5.
doubt.
sir,
Wait. Doubt.
doubt regarding 4 comma 2 only.
Yes,
Because
tell
the
me.
element A will take from set B, no?
Yes,
So we cannot write 4 comma 2, na? It is
yes,
4.
that is true.
So yeah,
So
yeah.
who has given this
10,
input 4 comma
5.
2? This is
Sir,
should be rectified.
I only gave it. Was my
Yeah,
mistake. I understood now.
yeah. So now tell me the correct elements.
9
So
comma
9
9.
10,
comma 9
5.
10 comma 5. This is one. Okay. What else?
9 comma 9.
and 9 comma 9.
9 comma 9. What else?
9 comma 3.
That's it, sir.
Sir, 9 comma 3.
9 comma 3. Okay. Any other element?
So how 9,3?
Sir, how 9 comma 3?
I don't know. Someone told.
Sir,
A
both
is
9
multiple of
and
B.
3 are from set C.
Hmm?
So
No,
that
ma'am. No, sir. Set B also
3.
has 9.
But what
Your
about 3?
property should hold for all A and B where A is belonging to B and B is belonging to C. So 9 is belonging to B. This 9 is belonging to C. Property is holding. A is multiple of B. What is
Sir,
wrong in
10
that?
comma 2. 10 comma 2.
Okay. Very good. Any other thing is, are we done or any other elements are there? Come on, conclude quickly. Are there any other elements belonging to R3 or we have done?
Sir, yes. 10, 1, 9, 1, 2, 1.
10 comma 1.
10, 1,
10 comma 1.
9, 1, 2, 1.
9 comma 1. 2 comma 1. Any other elements or we have done? Are we done or any other elements? Yeah, come on, conclude. Whether we have finished or still are there any elements? Someone please unmute and talk. Viraj, are there any other elements or we have completed?
So, khatam.
Pardon?
Done, sir.
Done. Okay. Let's proceed ahead. R4. So work out on this and let me know what are those elements.
Four comma two.
Hmm.
Then 2 comma 2, 1 comma 2, 1 comma 1. Sorry, 1 comma 1. 9 comma 9.
Hmm. Don't stop. You just conclude whether this is completed or not. Pardon?
5,10, sir.
I'm not getting repeat.
5,10.
5 comma 10. Is it right? Is it right or wrong? Come on, conclude. All students. Is element 5
Sir,
is belonging to set B?
No, no, sir.
Then
Sir.
Wrong, sir.
Wrong, sir.
no. What I am saying, this is element B or element A, first of all. You need to understand. We are writing a pair A comma B. A comma B. Okay. And in that, B is divisible by A. So whether this A is belonging to set B, whether this 10 is belonging to set C, yes or no?
So 10 is not belonging to set C.
And whether 5 is belonging to set B,
No.
so
No,
this
sir.
is not there. This element is
sir, for
absolutely
the
not there.
first one, it is interchange 2 comma 4.
Okay,
2 comma 4.
very good. Any other elements? Or we have done? Yes, Gauran?
Sir, done.
Gaurav, sorry. Done. So this is just one of the example how we write the R. That's it. And what are the operations that we can perform on R? That are very pretty clear. Whatever, see, whatever R we have got, it is a set. Basically, this is a set. What operations we can perform on set? Union, intersection, set difference, complement, whatever operations that we are performing, Cartesian product, R1 cross R2, all such operations are also applicable for the relation because relation is also a set. It is containing ordered pair A comma B such that A belongs to set whatever the A belongs to the domain and B belongs to codomain in general. That's it. So coming back where we are, is it clear? Any questions? Please respond quickly in the chat box. Any questions or is it clear? Yes or no? Quickly give your feedback. I am waiting for the feedback. Any doubt? This is the right moment to ask the doubt. Okay, let us proceed ahead. From where we started. Okay. So what we will do, we'll try to understand the properties. We want to classify the relation. What are the various patterns of relation are? Okay. So we just now concluded that a binary relation from set A to set B, it is also R is subset of A cross B. It is collection of all the ordered pairs A comma B such that A belongs to set A, B belongs to set B, where set A is called as domain, set B is called as codomain. That's it. When we say A comma B belongs to R, we say that element A is related to element B, and it is denoted something like this, A R B. When we say A comma B do not belongs to R, that means A is not related to B. So just have a note of this. Let's proceed. This we completed. This also we completed. Yeah, these are the various properties of relations. Reflexive, symmetric, transitive, antisymmetric, asymmetric. Let us try to understand these properties. In a relation on a set, if all ordered pairs A comma A for every element A belongs to domain appears in the relation R is called reflexive. So when we say a relation is reflexive in a simpler manner, so up, downward A is nothing but interpret this as for all, for all element A belongs to set A. Acha. This reflexive relation is holding only for set A to set A. This property we are checking, reflexivity. When we say whether the relation is reflexive or not, it is applicable only when the relationship is from set A to set A itself, where the domain and codomain is the same set. Only for that set we are checking the reflexivity property. Okay. So what exactly the reflexivity? For all the element A belongs to set A, if A comma A means every element is related to itself, is present in relation R, then we say that relation R on set A is reflexive. So example, let us take. So for example, if we do have some relation on B R1, B, this is some relation, okay? And let us take the same example, what we have discussed here. R1, that is A is A is lesser than B. So what are those elements? Can anybody tell me now quickly? What elements will be there when we do have R1 relation from B to B? Come on, unmute quickly and tell.
1, 1, 2, 2, 9, 9, 10,
1,
10.
1, 2,
2,
1,
2.
1. 1, 1. 1 is less than 1.
Oh, sorry. Acha, I did not see that. Then 1, 2.
1, 2.
1, 9. 1, 10.
Okay. So I am giving you now another relationship, that is let us say there is another relationship R2 and B. So come on, tell me now quickly.
Sir, now it will be 1, 1, 2, 2, 9, 9, 10, 10.
Ten comma 10. Okay. I am giving another relationship. Let us say B R5 B. This relationship is something like this. R5 is hmm, let us say A is greater than or equal to B. Okay. So come on, tell me now the elements.
Sir, 1 comma 1,
Hmm.
2 comma 1,
Hmm.
2 comma 2,
Hmm.
5 comma 1, sorry, 9, 9, 9, 9
Hmm.
comma 1, 9
Hmm.
comma 2, 9 comma 9,
Hmm.
10 comma 1, 10 comma 2, 10 comma 9, 10 comma 10,
10 comma 1, 10 comma 2.
10 comma 9,
Hmm.
10 comma 10.
Okay. So what exactly we want to learn from this? Just a minute. So what is our property reflexivity? When the relation R is reflexive, when this relation R is applied on set B to set B, means R is applied on a particular set. Same set is acting as a domain as well as codomain. Okay. So what is the definition when we say the relation is reflexive? When all the elements belonging to set in general, now I am talking here, coming back, for all the element A belonging to set A, if we do have A comma A belonging to R, we say relation R is reflexive. So can anybody tell me now, R1 is reflexive, yes or no?
No.
Why no? When you say no, how to justify the answer? At least one counter example you need to give. What is meaning of counter example? What is our definition? Our definition says for all A belonging to A comma A also belonging to R. So if we do not hold this property, one of the example we need to give such that this property is not holding. Means what? For example, for example, element belongs to element 1 belonging to set B, but 1 comma 1 is not there in this relation R. Therefore, this property is not holding. At least one counter example we need to give. Okay. Now coming to the next, is this relation is reflexive?
So second one.
Yes,
Yes, sir, it
I am
is.
Yes, sir, it
highlighting
is.
one. Yes,
Sir.
yes. Is this relation is reflexive?
No.
Sir, but it has that element, no? So, I mean, all the elements should be like that, or even if one element is
All the
in this.
elements.
since it is the end of the time, request everyone to post your